So Chris, I'd like to come to you for the first question. The UKSA has recently funded several studies looking at this issue of atmospheric ablation of re-entering spacecraft and the potential impact on the atmosphere. Why did the agency feel that it was important to conduct this research now, and where can this audience go to learn about some of the findings and next steps?
Thank you, Ian, and thank you for hosting this panel as well. And the UK Space Agency is a long-term friend of SWF and a global partner of the summit, so yeah, really proud to be here. And thank you also for co-hosting a workshop yesterday with the UK Space Agency on this very topic, so it's very apt, the timing of this panel. In fact, the catalyst for the UK Space Agency funding research on the atmospheric impacts of re-entry and ablation came out of a Secure World Foundation Summit a couple of years ago in London through a side chat. So there's very much evidence of the positive impact that can come from conferences and summits like this. But essentially, the UK takes its responsibilities of acting in space very seriously. We have the fourth most number of satellites in orbit, and so we have a responsibility to act in a good and responsible manner. And when it came to re-entry and the effects of re-entry, we just didn't know exactly what the impacts of those would be. So we wanted to understand that so that we could act in a more responsible manner. So we commissioned 4 pieces of research on this topic, and they've just concluded, actually, and you can read them in more detail on a UK Space Agency blog. And I'm not a chemist or a physicist by trade, so I'm probably going to butcher the detail. But as at a high level, well, the first study that we funded was from the University of Durham, from Fiona Thompson, and she did a sort of a literature review gap analysis of exactly what we knew and what we didn't know. And broadly, the conclusions were, yeah, we really don't know anything. We know we don't know much, but we really don't know much about what the atmospheric impact is of re-entry and how exactly ablation can work. And there's not much available data that's validated as well to make informed decisions as to how we can regulate, if necessary, through the licensing process on this issue. The second piece of work that the UK funded was from the University of Leeds, and this was co-funded with the European Space Agency with John Plain, and they were really looking at the atmospheric chemistry of re-entry and how particles move around the Earth's atmosphere as a result of man's activity in space. And broadly, the sort of conclusions that that's coming to is that, yeah, there is evidence of man-made spacecraft material, metallic material depositing in the polar regions, and there is evidence that space activity is causing environmental harm in the polar regions due to the atmospheric conditions. Then thirdly, we funded a piece of work from Belstead Limited with James Beck, and this is where it really got into the science, and we were looking at the particle level physics of what happens to aluminium in particular under sort of high velocity, high temperature conditions, and trying to recreate the ablation process under lab conditions. Yeah, so very complex vaporization evidence that they were trying to replicate there. Again, this is sort of where it gets difficult because it turns out that the size, the shape of particles really, at that molecular level can affect the ablation process in very different ways before we even start thinking about the types of different re-entry or shapes or materials of spacecraft and how that might affect it. And there's this big assumption that we should only be focusing on aluminium at the moment because that makes up the biggest mass of spacecraft, but this is sort of a huge assumption for all our work that we just want to focus on aluminium first. And then finally, it's actually a piece of work that you were part of, Rachel, led by the University of Southampton and Min-Kwan Kim, and also Secure World Foundation. That's sort of a very widespread study looking at the hybrid approaches and recommending some prioritizing and proactive modeling approaches. So yeah, you can read all of those in more detail on the UK Space Agency blog.
Thank you, Chris. And I believe both Fiona and Min-Kwan are also here in the audience, so perhaps a chance to find them at the break and chat a little bit. So turn now to Ogwill. So before we can ablate a spacecraft on reentry, it has to first be launched. And so I think we are mindful that there is a launch emissions part of this conversation as well. As space activities increase, we're seeing more launch activity. From the research that you have been involved in at CNES or elsewhere, what do we currently understand about the possible impacts of launch emissions on the atmosphere and the uncertainties there?
So thank you for organizing this panel. Thank you also, Jose, for the introduction. And maybe I can complete a little bit this introduction by explaining the possible impact of launches. So yes, rocket and launches are complicated way of moving, and we are passing through the different layer of the atmosphere, and by doing it we are emitting some particle at this different layer at different characteristic, and this can have impact on radiative forcing, but also on the ozone layer especially. So on CNES we are working on the environmental impact of space activity since many years now, and in launcher department where I came from, of course, we are having some studies on the impact of the launcher. What are the current knowing is that yes, to reply to this panel, possible impact. So because it's on human activity, there is impact. The question is how much impact, and the question is it a positive or a negative impact? But it's not because it's positive that it's really positive impact. But so yes, so what are we now? What we know is that yes, we have impact on the ozone depletion. How much we can't reply to this question. It's the same that with ablating reentry, because it depends highly on the shape of different particle who is emitted, and also to the size of the particle. So yes, we can say that we participate to ozone depletion, but how much we don't know. Is it in the planetary limit? We don't know. So we have to better know. On radiative forcing, on launcher part, it's also depend on but ozone too. It depends a lot on the different rocket engine that you used. Having said that, don't answer the real question is how much we impact it. So we have clue of categories of impact. But it's not because we have an impact at one layer of the atmosphere that we have impact on the ground. So to be completely clear, so we may warm up the stratosphere, but on the troposphere, we don't know. It depends. It depends because there is many adjustments to make between the two. And today, we are not able to say that, yes, this is the impact of each launcher. We don't know. So we have to better know. And what are we today? So we have to characterize concretely each type of launcher and each type of emission to be able to really know how much and which sign is the difference of our activity in the radiative forcing today.
Thank you, Chris. Thank you, Ogwill. So what I'm hearing from your remarks along with José's is, yes, we see an indication of impact, but impact alone does not really tell us too much, right? We don't know the magnitude, we don't know the directionality of that, we don't know the duration of it, and I'm hearing atmospheric chemistry, I'm hearing materials science, I'm hearing particle distribution, right? There's a lot of levels to this. There's not simply just about, we know that particles are coming out. So there's a lot there. So Chris, unlike you, I did do a degree in chemistry. I did my first undergraduate degree in chemistry and promptly realized I was a terrible lab scientist and moved over into the policy side of things. And here I find myself in an issue where chemistry is involved. But Rachel, I do want to turn now to policy. Part of the study and the role that we were involved with, the UK funded study, was looking at the policy, regulatory, and law questions involved here. Rachel, in listening to the situation described by our previous speakers, is the policy and regulatory system prepared to help reduce these uncertainties that we're talking about here and increase information exchange around this challenge? What gaps do we have on the regulatory and policy side of this challenge?
Thank you very much, Chris, and thank you for inviting me to speak on this panel. When you say prepared, I think there are two questions. One is there a willingness to address it? And secondly, is there a capacity to address it? I think in terms of the willingness to address it, it was an unknown. It's now possibly a known unknown. And we can see a number of organizations and national bodies beginning to engage with this. The UK Space Agency has obviously been very involved. We can see ESA with its circular economy approach is beginning to engage with questions of atmospheric pollution as well. So it's beginning to change. But in terms of capacity, I think we have major problems because this is calling on a number of bodies to rethink the way in which space has been regulated in the past. The focus has been very much on a coordination and safety issues, but here we're talking about environmental aspects, incremental aspects that may arise only some long time after the ablation, these satellite reentries have actually occurred. And this is a real challenge, I think, for the regulatory environment to address. I think there are three main issues that we can see here. There's a question of data collection, there's a question of primary research, of understanding the field, and then there's a question of regulation and policy development in this field. And I think in each of these areas, we have a very fragmented environment. In terms of data collection, we have different systems of data collection. We have important repositories that are being developed through the UN, through NUSA, as a result of the Outer Space Treaty, which requires states to the maximum extent possible to transfer information for further transfer to the scientific community, to the UN. We also have the Registration Convention, and we have national licensing processes which collect lots of data. We have quite a fragmented situation. The same for the policy context. We can see organizations such as COSPAR carrying out important scientific research. We have ESA, a very, very fragmented passion. And it's the same at the regulatory system too. If you just think about the UN, we have a whole plethora of different agencies and bodies with different focuses. I won't mention them all. And if I fail to mention some of them, it's not because they're not important, but you can think perhaps the COPUOS with its scientific and legal committees. You've got the ITU, which is involved with spectrum allocation. You've got the UN Environmental Programme. You've got the World Meteorological Organization. You've got the international body that deals with civil aviation. So there are a range of different bodies which are quite specialized and have developed with particular focuses. They may touch on this particular area, but they're not directly focused on this area. And I think that makes it very difficult to develop a coherent approach, given the uncertainties that we face at the moment. So I think the problem is not so much that we may not have techniques that we can use and that are familiar to us. It's that we don't have coordination and leadership to try and link up these groups and to decide what particular role each of them can play, either in providing the information that we need or thinking about the policy and regulatory solutions that might or might not be appropriate when we know a little bit more about this particular area. And I just wanted to end with just an important sort of emphasis that underlines what I've said, and it comes from the International Law Commission Guidelines on the Protection of the Atmosphere 2021. And Guideline 9 says that states should promote the interrelationship among relevant rules on the protection of the atmosphere and other relevant rules of international law, which should be interpreted and implied in order to give rise to a single set of compatible obligations, in line with the principles of harmonization and systemic integration, and with a view to avoiding conflicts. And I think this is an important reminder to us that we need to work together, we need to coordinate, and we need to have systems that can begin to pull these disparate communities together, working together.
Thank you, Rachel. Yeah, and I think from the remarks so far, the interrelated nature of this challenge is very clear. The different disciplines we're talking about, the different types of impacts, the fragmentation of the regulatory and policy system, both internationally and even at the domestic level. And then the second part of that guideline that you're talking about, getting to that coordination and getting to that harmonized solution, that's where we need to have a lot of conversation on. So, all right, we've heard kind of the research perspective, the academic work in this area. I want to now turn to the industry side, the operator side of the discussion. Vijay, from your perspective as a satellite operator, what is your reaction to the research questions and uncertainties being presented here? Are you doing any internal research on this topic at Eutelsat? And what role does industry have in understanding these challenges?
I'm lost.
Excellent. Excellent. Yeah.
The difficulty that I have as a responsible operator is, in this particular case, I don't know what to do. Let me take the other example that you mentioned at the beginning, which is the dark and quiet skies approach. There's a clear, for want of a better word, requirement. There's a target that's internationally agreed for a level of magnitude that comes from the user community, the astronomical community, and they say, if you're brighter than that, it's going to impact our operations. We can then try, in terms of number of satellites, the satellite surface material, as was mentioned earlier this morning, to mitigate that solution. But you can do a direct measurement of magnitude and find out whether you're compliant or not in orbit. The quiet part, under the control of the ITU, there are electromagnetic emission control techniques which are known. You use them to stop your house being irradiated every time you turn on your microwave at home. Okay? It's a slightly more complicated variant to that, but that's something that can be done. And also, directly, if you're not doing it or you're not doing it adequately, you can measure it. With an antenna, you can see what the spectrum is. So it's possible to react proactively from a design phase, from a manufacturing phase, from a validation phase, to do something to mitigate those issues and ensure that we have the darkest and quietest skies possible. In this domain, it's much more difficult because I have to launch. Sorry. Once I'm up there, I've got to make sure that I clear out my office. My office I refer to as an orbit of 1,200 kilometers up. That's where I work. Once I'm done, I need to clear out my office to make sure I can keep working there in an efficient way. It used to be the case that I had to clear my office once every 25 years. Okay? As of 2024, as Lionel mentioned this morning, I've got to do it in 5, which means I've got to come down 5 times faster, or I've got to bring that mass of product back quicker. I've also got to make sure that when I bring down 5 times as much, okay, it doesn't land on all of your heads, including mine. There's a technique for that based on models and tools which are recognized by the regulators, and I feed in some numbers into those tools, and a number comes out saying this is going to land on somebody's head or it's not. As long as the output from that tool gives an answer that's compliant, I'm okay. But it's a tool, it's a model, and what we're hearing here is that it relies on material that's in space not getting to the ground because it evaporates, ablates, demises in some way by some mechanism. And it's basically, if it gets hot enough, it'll all disintegrate into atoms and it'll all be fine. what we're hearing today for this particular one is we're not sure where those numbers come from. And in addition to that, I don't want to come down too much because it may be the case that I'm dumping too much of the wrong material, aluminium and anything else, okay, somewhere in the atmosphere from José's graph, anywhere from 20 kilometers up to 70 kilometers, where I can't measure what's coming in, and it may have a really adverse effect on the atmosphere in those layers. So once again, I'm lost. By the way, I've got to launch my next constellation by 2026. So as Arti said, she managed with one particular topic to get COPIS to work very, very quickly. I need all of us to work very, 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 very quickly because I'm building hardware at the moment, and I'm very happy, and I want to put the right technical requirements for me as the operator customer onto industry so that they can build what I need to operate and take it up and bring it back down without damaging anything from 0 kilometers to the von Karman line. Help?
So we need to walk out of this room today with a clear instruction to help Vijay find his way forward. Is what I'm hearing.
I'm here until late. That's not a problem. I live in Paris, so.
But to be less flip, right, Vijay, what you're telling us is, okay, if we say there's a potential challenge here and a potential impact, we need to really focus in on measuring that in a way that is operationally and, I'll say, risk managemently relevant so that we can do practical steps forward in a context where we want to deliver benefit from the activities that we do, and we have to realize that we have operational and business objectives to achieve as well. Right? So, Catherine, turning to you. So deorbit, you're not an operator in the way that Eutelsat is, but you interact with a wide part of the space mission value chain, I'll say. How would you characterize industry engagement and awareness of the topic we're discussing today?
Thank you, Ian. I think the awareness is coming around also because obviously industry has its eyes open and ears as well, and this topic has been circulating for a little while now. And I want to maybe add a little positive note to the picture through Deorbit's sort of philosophy of business, because Deorbit is a benefit corporation, and that's a very, let's say, unique species of corporations. So we have as a bylaws incorporated benefit purpose to conduct our space activities in a sustainable way. And so this objective that is incorporated into our bylaws has to translate into viable and concrete actions that Deorbit introduces as a company in its operations. And one of the ways it has translated so far is our advanced services business line, where Deorbit offers our ION satellite carrier as the vehicle for hosted payloads. And I think at least partially that contributes to reducing the return of whatever is launched into space, because ION satellite carrier can host payloads from 1 U size to 16 U size and up to 200 kilogram currently cargo. So that means that instead of having ultimately 16 U's of satellites, we host the payloads, so the brains of the satellites, the core technology of such maybe future satellites or spacecraft inside ION satellite carrier. And so instead of additional 16U volume, we only have ION that goes into space and then comes from space and burns up in the atmosphere. And in addition, I think the industry, especially now in Europe with the proposed EU Space Act, we will have to react to the eventual responsibility and obligation to have the environmental footprint audited for the purpose of being authorized to carry space operations and space activities that spans from literally spacecraft design to the finishing phase of reentry. So necessarily the information and data and the impact of let's say the reentry part activity will be then counted in the overall footprint, and I'm sure that this compliance requirement will result in better information that we will have, and I'm sure that industry will also be open to any collaboration on data collection. You know, if a spacecraft can be used or equipped with any type of sensors that can be useful for this purpose, I think it could be doable for the common purpose.
Yeah, so looking out for collaborative opportunities to develop some of these things. And I think a plug, we will have a presentation later this afternoon from the Commission, and I believe PFCR, the footprint rules, will be discussed a little bit in that presentation later this afternoon. All right, I want to turn now from some of the discussions of these uncertainties and the intersectionalities to maybe some of the ways that we can consider strategies or approaches or steps towards reducing those uncertainties and increasing that information exchange. And we will try to work in some audience questions here. I've noticed a couple already, so if you do have some audience questions, please do submit those through Whova, either in the app or online. So Chris and Ogwil, I want to start with you just kind of briefly. From the agency perspective, what role do space agencies have in helping us improve our understanding of both the ablation and launch emission side? Do agencies have a role, for example, in improving information sharing or enhancing our ability to collect in situ observations? So it's for both of you. Yeah.
Hi, I'll start there. So I think agencies have a really vital role to play in answering some of these questions, but also in enforcing good practice to mitigate against the potential issues and impacts of activity like this. Clearly in the UK, the Civil Aviation Authority in the UK is the one that licenses operators to license in space, but they take their implementation of the licensing process from the UK Space Agency. So we advise them as to exactly how to police and implement these rules. And so on this particular issue, we cannot offer any advice at all as to what rules to implement, because there is such little data to show what good practice we could implement to negate whatever impacts that we're unable to quantify. And so rather than this being a product that as a space sustainability team I can implement, all it is at the moment is a sort of an unquantifiable risk in my space sustainability sort of program, which is just sort of running in the background at the moment. So data sharing amongst agencies, really important to be able to answer and inform some of those questions. Obviously then, the international collaboration is and the coordination between agencies to share data on this is absolutely vital. This is a global and a planet-wide issue, and it's not just a UK issue or a single nation-state issue. Nevertheless, even if we were to act in a proper way and a responsible way, we wouldn't be making a dent in the problem, because there are other operators that are re-entering a much higher density of mass every year more than the UK. So this is something that we need to recognise as sort of a humanity issue and a global problem, and it's something that can't be solved as a single nation state or even as a regional matter. It needs to be on an international multilateral phase. So I think things like the UN are really, really helpful in collating and pressuring nations and agencies to prioritise work and research in this area, to collaborate and share data and information so that then the rules of the game are consistent across nations as well, and we are then able to see reliably the impact of the regulation that's being put in place. If there's inconsistent regulation and rules of the game being implemented across different regulated countries, then it's difficult to then say, yeah, the atmosphere is improving in health, or actually we're making no difference and we need to go harder and faster, because ultimately we have no choice. As you said, Vijay, there is this balance between safety and sustainability, but when it comes to human safety, there is no compromise at all. Design for demise has to take priority, but obviously the impact of that is this ablation issue that we're talking about. And so until we can quantify that in a better way to make sure that we're mitigating it in an appropriate way, the human safety aspects of it will take priority.
Yes, I agree. So, of course, there is a regulation and authorization. Space agency have a role in this. And we also can play a role on collecting some data. So, yes, for now, we are not sure to being able to say that this data mean each impact, positive or negative, but we can try to already have some data. For example, in the French Space Act, in the last update, we asked for people to tell in the launcher part on each layer of atmosphere which gas is emitted, for example, and at the end it will help us to better understand this issue. Of course, we can also, as a space agency, help to have a common understanding and also to create forces to move on this subject on the French level. So we have my general director told before, we have made a French decarbonization roadmap. On this roadmap, there is a clear highlight on better understanding the high atmosphere impact. So it is a statement that we have to better know, and now we are working with French industry, French researcher, and all the stakeholders here to make a plan to better understand this, and in a French way. So, as I was saying before, we need to characterize. It's one answer, and for that, space agency can also help. So, in my space agency, we are working to see with satellite how we can see the different launches with balloon also, because we have. Many experiences in balloon, but also, of course, in the different launcher. In each country, there is different launcher who want to be launched in the coming years. So I invite all space agency to talk with all the different launcher of their country and to work with them to better understand what are their impact of the launches. On French side, we are doing it, and we also. Of course, as a space agency, we are a force that can help to cooperate on this subject, to have a common agreement on which are these impacts, because if it's only France who say this is the impact, UK will say this is the impact. Maybe it's not the same way of seeing the coin, and we can help. And at the end, I think we can also help Vijay to say, yes, on launcher part, maybe this launcher have less impact. So please select it. And so it's for the launcher part, but on the satellite, I'm guessing it's the same. So yes, we have many ways to help, I think.
Yeah, so one of the points I think I pick up both in Chris and Anwell, there's actually a question in the audience about that. Maybe some of the research findings aren't fully validated, haven't been gone through the full scientific method, and then fully repeated in some of the analyses, right? So, and you mentioned different agencies come to different conclusions. I think one of the roles the agency community does have is potentially providing a forum where research results can be shared across different agencies. You can have that technical interchange and maybe do some of that validation. That may be one role in particular that agencies are well suited to play here. As they questions go to sleep. So Vijay, back to you here. See if we've helped you navigate through the wilderness here. One of the gaps we're talking about here is just basically that our knowledge of materials, actually, how materials are actually used in satellite construction, and then how those materials then behave when they're blading, right? We don't really know a lot about that right now, if I can paraphrase the discussion. As an operator of a LEO constellation, as a member of the satellite operator community, what pathways do you see to reducing this potential knowledge gap around materials behavior? For example, can we enhance data sharing around satellite composition and manufacturing, the materials we use? Can we improve reentry observations as an operator? Is that a role that you see?
I see 2 or 3 things that we can do. If I understand the requirement number 1 is what is the quantity of material X in space that's going to come down? So we know the number of space objects, and we need to get a better handle on how they're made up and what materials. I think that's something that can be obtained already, because the same information is required as the input to the various demisability tools that we use today. DAS, Drama, etc. There is an input file, and most of the information there is, it's this material, this quantity, this volume. That information exists, and it is being provided in a way that industry can provide it without giving away design information. If you say that you have a satellite that is 150 kilograms, and in it has 7.5 kilos of aluminium, okay, I don't think it can be argued that that is giving away critical information, and that you can reverse engineer a particular satellite design based on that information. So that part of the information collection, I think, is there already, and it's part of what is provided to the agencies who generally do the technical evaluation role for their regulators. That information is there. What worries me more, and you mentioned it, Chris, that if it's a choice between safety and sustainability, it's human safety. Okay? I'm confirming to you that my satellites are safe, because I'm telling you there's 0 kilograms of anything coming on the ground, based on a tool that doesn't know how to correctly model the ablation process, which we're relying on to ensure that things burn up. So I think it's safe, but that's the key point where I think the focus needs to be for the funding, for the direction of the research from the agencies, the international coordination effect. That's where the push needs to be. I think it can be on-ground modeling. We have to combat the difficulty, as Jose mentioned. The interesting zone is 20 kilometers to 100 kilometers, and we've got to get stuff that actually fly there, or by a radar technique, or by a spectroscopic technique, something that we think will work and allow us to get a better breakdown of what is actually there. I would be happy, and we've done this in the past with satellites where agencies, for example, have provided radiation environment monitors, which regularly fly on all the spacecraft, and you get a better mapping of what the outer space environment is like, and then that is able to correlate ground-based models. We could, I think, develop the sensors which transmit up to the point that they burn up to get a better idea of what the composition is and what the breakdown mechanics are. It's an idea, and that's something that you can put into every spacecraft platform design. That's another way of doing the in-situ measurements, but that's one of the big problems. And behind that is all of the lab-based work, the research, the theory of the ablation processes, and what you actually break down into, assuming that you start with, I think, a fairly reasonable database of what quantity of what material you have.
So we have a starting point to build from that, right? And then, yeah, you're suggesting some methods and approaches that we could do that. But I especially like the point, Vijay, because I've heard that materials are proprietary. you're challenging us to think that we can report that data in an aggregate way that it is not, right? Yeah.
I think we can get enough information with what's available in the databases already without going to that proprietary level. Whether it's 3% of chromium or 3.5% of chromium in company X's AL7075, I don't think any of our modeling is going to be that precise. It doesn't need to be at that level.
Yep. All right. Thank you. So, Rachael, coming back to the legal policy side of this, and looking at environmental law, does our existing practice, requirements, conventions, and international environmental law, does that provide us any instruction or methods for enhancing reporting around an emerging issue like this? Is the precautionary principle something that applies here? Just share some of your perspectives on that.
Thank you. And just before I try and answer that challenging question, I'd like to say that I think safety is obviously a key priority. It is a key priority, but it's not the only priority. So it's a priority, but I think this is also something that we need to address. And as Vijay said, we need to address it quickly because industry needs to know what they have to do. They have policies and plans in place for design and all the rest of it. But this is also something that, if we're talking about the ozone layer, could be quite significant. So I think it's important not just to say space security and safety is the priority and suggest that I know you weren't suggesting that, but I think that could be seen in that particular light. In terms of what we can learn from the environmental field, what I was saying earlier was that there are these different institutions, particularly at the international level, which have different interests and capabilities. And I think in terms of this particular issue, we can break it up in different ways. We can think of it in terms of being an industry issue, a space industry. We can think of it as being an effects-based issue, atmospheric effects, pollution effects. We can also think of it in terms of being an issue that relates to specific domains. Are we dealing with the terrestrial environment or the space environment? We can also think about interests in who is participating in this particular body. So there are different frameworks for thinking about where should leadership come, which particular bodies or organizations might be involved in this. And I think that we can learn a lot from the environmental field and the international environmental law. And I think this is in part because they've developed conventions and approaches over a considerable period of time that we can learn from. For instance, they have developed specific technical committees. We can see within the multilateral environmental agreements relating to, for instance, ozone, the specialist technical committees that can evaluate the literature and can support the development of models. You can think about the independent panel on climate change, which has played a very important role in trying to think of approaches and standards and ways of evaluating impact. Secondly, I think we can see some very interesting coordination developments at the European level, at the environmental level. For instance, the clearinghouse model, which has been developed in the Convention for Biodiversity, which deals with a similarly complex issue with a whole range of international, national, private industry organizations that are involved in this issue. And it has a very long roadmap going through to 2030, which really works out how we can coordinate among the different national agencies, the international agencies. So I think this is a sort of a ground which we can draw from. The other thing is that we can see, I think, from the environmental field, quite an innovative approach to developing international law. In the ozone field, for instance, the first ozone treaty was 1985, and it was a framework convention, just as the climate change convention is a framework convention. It doesn't in itself set down the standards, but say that we have to work to address these problems that could relate to ozone, and I think it covers exactly these issues now. We have got a treaty, a 1985 treaty, that says that states should cooperate to address concerns in terms of ozone depletion. But then there are protocols that build on that, build on the knowledge and the research that's going on within that particular environment to come up with concrete standards and expectations and guidance and good practice as a follow-through. So I think that's quite an interesting model to look at and think of, although we have the time frame that we have to deal with here, which makes any kind of international agreement difficult, but a framework convention might be somewhat easier as a first step. The second question was in relation to the precautionary principle, which is an important aspect of international law. And we talked about the willingness and capacity of organizations, states to engage with this, but I think there was also not just a question of capacity, but a question of legal obligation. And as a matter of international customary law, there's an obligation on states to act in such a way that they do not cause substantial, significant harm to the environment, either in the territories of other states or in areas out with national jurisdiction, which includes the atmosphere, the high seas, and outer space. This obligation to prevent transboundary harm is an obligation that includes an obligation of due diligence. You have to carry out an investigation, you have to assess the risks, and that assessment becomes increasingly important as the envisaged harm is seen to be increasingly significant. The problem that we have here is that we don't know the nature of the problem. We can see there is a problem, we can see there is some impact possibly on the ozone layer, but we don't know how significant this is and what the implications might be for the industry itself. And this is where the precautionary principle comes in. It's a guideline that informs that due diligence obligation. And it says that even if you don't have the scientific information, where there's a plausible case for saying that there could be some form of significant harm, you have a duty to go in and actually carry out the research, find out what the risks are, coordinate, collaborate, and try and resolve it. And I think that's where the precautionary principle is coming into play here.
And that's I think a theme that's coming out, right, is that the obligation or the need that we have right now is to really focus in on narrowing that uncertainty down, doing the collaboration, facilitating the research, and having that exchange. So, Catherine, going to come to another potential mitigation approach that we might think about. It's already been mentioned in an earlier session. And that is the idea that maybe we don't have to ablate all of our spacecrafts. Maybe we can find ways to reuse material in orbit and not necessarily have to deal with return. Then this is the idea of the idea that we might move towards a circular economy in space. From deorbit's perspective, how feasible is this, the idea of a circular economy in space, from a market and technology standpoint at this time? And what actions can we take to kind of put us on that pathway?
Well, since it's one of the deorbit future business lines, we sincerely hope that there is the business case. And I think with the current trend with more significant support for iOS, in-orbit servicing, maintenance, and then the more forward-looking perspective of reutilization of resources in space is to me significant of the potential that it does have in the future, probably not very near, but hopefully not too far one either. And as the Orbit CEO loves to underline, you don't build ships in the desert to bring them to shore, but you actually build them close to the water to economize on the distance of making them operational. It does make sense to build spacecraft in space, and that would certainly reduce the impact of launching and reduce the hopefully re-entry, and will teach us how to reutilize the materials that we already have sent to space, and with let's say, a futuristic perspective of living in space, we will have to certainly learn how to recycle everything possible, since we still don't have the capabilities tested enough that we can extract new materials directly in space and move forward with space manufacturing from actual space resources. So why not start with something that we as humans already have sent up there and recycle it, so that we can also economize on use of resources on the Earth rather than keep digging them up to send them into outer space. And I think moving a little bit on a shorter term perspective, the idea to have spacecraft that are capable of combining several missions in one launched spacecraft could also be something that would help reduce the volume that we send, especially if we talk about the capability to miniaturize technology, to make it more efficient. Then whenever the opportunity arises not to have a space object that is dedicated to just doing one thing, why not making it doing multiple things in one shot, and thereby sort of spare on multiple launches of several spacecraft that will do just one narrow thing and just open up the capabilities of individual spacecraft.
All right, thank you. So, all right, watching that clock rapidly dwindle here, I'm going to try and get to some of the audience questions. We have several questions in here that pick up on this theme of design for demise, and whether that is really kind of the guiding star that we should be following here. And so I guess the question that I want to ask based on that, I think the issue that's been pointed out in some of the audience questions is that there may be trade-offs here, right? We have best practice for space safety that is 5-year deorbit, design for demise. Here we're seeing that maybe those things may have some effects on other important values and important aspects. So I think the question I want to phrase is, how do we evaluate these sorts of trade-offs, right? We've come to design for demise and 5-year deorbit from a long period of research and operation practice, right? We don't have that for ablation, as we've heard. What indicators should we be looking for? How should we be preparing ourselves for these as a policy community for these potential trade-offs? I know it's a big question, but I guess maybe what I'm trying to get to is just viewpoints from the panelists on where we see these trade-offs. Yeah.
Shall I start? So obviously space sustainability covers a number of different policy and delivery areas. So this is a multifaceted approach. It's not a sort of a one solution can fix all approach. At the moment, design for demise sort of is the only solution in low Earth orbit, really. And so it's all we have to mitigate against debris, which is seen as the most important issue for space sustainability. And I think more and more as we have more and more reentries, what I would expect is that ablation will sort of increase as a priority. And this is where elements like you were discussing, Catherine, probably come in as parts of the pieces of that puzzle. I think ISAM solutions such as refueling, reservicing and repairing, building in space, these are not immediate solutions. They are sort of a low technical readiness at the moment, as far as I can tell, and they're certainly not mass solutions that can be implemented as an entire solution, but they are one part of the piece of the puzzle. And certainly, the logic that you lay out, that it's bonkers to build a ship in the desert, it's the same way to, this sort of one-use, non-recyclable culture that we have in space of we'll launch something to space and that with rare earth minerals that are of limited supply and then burn them all up in the atmosphere after one use. That is unsustainable. So I think ISAM is probably the biggest piece of that puzzle. But ultimately, you're right, this is what I expect is that there'll be a threshold at which will go a certain mass of material can re-enter the Earth's atmosphere per year, which doesn't go over a threshold of saying that it's unhealthy. Where that threshold is, based on any sort of metrics, is completely unquantifiable at the moment, and so we can't inform regulation or policy to inform a decision like that at the moment. So I think in situ data collection, which is really difficult at the mesosphere level. But one of our studies says that apparently only 7 reentries have ever been recorded in situ. And you can imagine the number of reentries that's taken place over the last 60 years. So really, there is very little data to say this is actually what happens during the reentry process, and this is how you can mitigate against the potential impacts of it. So there's a number of different approaches, but we need the data first.
So Rachel, you look like you got the microphone ready to go. So I would actually say there's questions about environmental impact assessments here and whether that might be our way out of this. So I'm going to throw that to you as well. But yeah.
Okay, I mean, just to follow up on that. One issue that we haven't really discussed but it relates to this idea of coordination, to make sure that if licenses are given and if spectrum is awarded, that it's given for sensibly scaled and coordinated constellations or whatever. So I think there's an issue, again, this is no one body is the solution, they're all sort of part of the solution. And the role of the ITU in spectrum allocation and overseeing that, I think, is very important. And just in terms of environmental impact assessments, I think, from the view from France and the view from the UK, we can see that these are important within the domestic systems. They could perhaps be expanded. I think there's been a tendency to focus on the ground base, that the launch sites, the launch, and not look at the longer term implications of the ablation at the end of the day and build that into an environmental assessment. As I think I've said when I was at ESTEC, I mean, we can't, I think, in terms of expect industry to be coming up with the information on that by themselves. They don't have the capacity, or indeed it would be inappropriate to do so. It's a sort of community problem. We benefit from space. We have a responsibility to deal with it. But I think within states, there is this obligation to, as part of that sort of process of licensing, to think about environmental impact and to take responsibility for that. So I think it is part of the solution.
Any other remarks from the remaining panelists on those two kind of convoluted questions that we weave together? All right.
My job is not on re-entry, but I wanted to answer maybe on my colleague. So I completely agree. We really need to cooperate on this, and I think that everyone here in this room should think, what are my company doing to better understand this on the re-entry, but also on the launches? And if you don't have the answer, it probably is a problem. So how now we can cooperate all together to, I don't know when will be the next summit, but at the next summit having another reply that we don't know.
I think that's a great challenge. The next summit will be about a year from now. We'll
maybe not a year from now, but at least maybe trying to create a plan, coordinate, and yes, to at least make some step.
Okay, so there's a couple of other questions in here about maybe we should be thinking about doing reentries differently, looking at lifetimes differently, looking at just different technical ways that we could approach ablation. Some of the studies, Chris, do talk about different mitigation strategies. I don't know that I necessarily have you respond, but I just say take a look at some of the information in the UK and through also through some of the ESA studies as well. That the potential of changing the speed or angle of reentry may change some of the ablation properties, and it is an area that we ought to look at. So, all right, very quickly, with the 1 minute we have remaining, I just want to ask each of the 5 panelists, as we walk out of here and not taking a year to come back with next steps, what is the immediate next step that you think we in this community should be taking on this issue? So I don't know if Agua wants to start or Chris, but Rachel? Yeah, no?
I think I would encourage the United Nations Environment Programme to think about this and to see how they can take a leading role in addressing it.
And so maybe we can look at expertise and experience and then other environmental challenges and bring that in. All right, Chris? Yeah.
Well, I think my first step is to take Vijay for a beer, and upon that offer, you're going to give us all the material composition data you've promised us. So low-hanging fruit. Thank you very much.
Materials composition
That'll
data
help.
is low-hanging fruit. Vijay, you got right to reply on that one. Yeah.
So first of all, I would love to go and have a beer with you, where I can show you that the information that you want, you already have. Well, actually, I'm going to go one step better than that because it's something that I would like. Okay, I think that either the documentation we've given to you as part of a license, or the information that we've given to you as the technical advisors to the ministries who give the license, okay, what you need is in there already. And I'm still wanting that beer. What I think we need to do, and I'm touching on something that Jose mentioned in his talk, okay, there is more and more material re-entering from orbit. That's the trend. Okay, so we've got more opportunities to try and measure what that is. I think the first step of research is in situ measurement is going to be tricky as far as we're concerned, because getting into that region is difficult. We need to see if we can develop new ground-based looking up techniques in order to characterize that, because there's more samples coming down. This is the time to do it. And if we start with a better characterization of what's coming down, then we can follow on from the impact assessment.
In situ measurement and doing that.
Yeah, I echo everyone that data is key, and without data it's hard to make informed decisions. But I think in the meantime, continuing incentivizing more sustainable practices across the entire sector will build the momentum, and push everybody to act in a more responsible, cautious way as a community and as an ecosystem.
Think about this incentively.
Yes, I already talked about cooperation, but I really want to insist for my last word about the characterization on the launcher part. It's very, very important. So we need to push on this to characterize all kind of launcher. So yes, I think that's it's a way to do it.
All right. So I think we said there's a fair amount of uncertainty in this topic. There's a fair amount of urgency in this topic, but I think we've identified some concrete clear next steps that can be taken. So I want to thank the 5 panelists, thank the audience. Apologies for not getting to all the questions, but I think we've had a very, very cross-cutting and useful discussion here. So thank you all.